a weekend, then we have a weekend, then we have a 3-day weekend. Is that close? Maybe.
You grow my turn.
Yeah. It's like the 29th. Maybe it's not for that. Anyway, it's done. Alright guys, here we go. Number 8. Okay, let's focus. Number 8 is a no, yes, no, no. Number 8, Brandon. Number 8 is a no, yes, no, no. Number 12 is final solution. 2, negative 3, negative 2. 2, negative 3, negative 2. Following, oh guys, it was a stair step.
It
Nice.
was pretty nice.
Wasn't it?
Yeah.
Yeah. Number 22.
Much love.
Oh, there was only 2 equations. They still did the stair step, but either way, whatever. Solution, negative 3, 2. Number 30. No solution, because we came up with, what did the math tell us? False statement. No solution. We did our system and we almost got there and it said nope, and we said okay. Number 42. Ugh. Did you guys do link by link? Did you notice that? Wait. This was different from yesterday. This one came down to a true statement. But we only had 2 equations once we got the true statement. Where did our third clue go? It left. So if it left, what do we let z equal? A. So there are, hold on, pause. We didn't get to look at an example of this yesterday. Yesterday we said, hey, whenever we have a non-square system, whenever we're supposed to solve and we don't have enough, we let z equal a, right? This one, didn't it look like you had enough? Looks like you had enough, but as you started doing your system, you went down to get your third equation and it said nope, and we said, but it's true. So we're going to do the exact same procedure as, well, okay, at least we have 2. So we'll make z equal a on this one as they did. And they back substituted to find y, back substituted to find x, and they were able to get the final solution. So if you guys got stuck on number whoever this is, 42.
Yeah.
0 equals 0. That was your clue to let z equal a. To let z equal a. And then plug in for y, plug in for x. Number 50. Did you guys figure him out? He was weird, right? Wait. Don't we have x's and y's?
Yeah.
How many pairs? 3. Why do we have 3 pairs of x's and y's? Because we are missing how many variables in our quadratic equation? 3. So if we plug in a point for the x's and the y's, plug in a point, don't we have a system of equations? And you guys aren't robots, you don't necessarily have to do the stair step. You can say, sweet, I know one, let's plug him in. Let's plug them in, and then let's have a system, a little baby system that we could do substitution or elimination to solve for the rest. And we end up with a is negative 1, b is 2, c is 3. Plug it in, and we have our quadratic. And they technically asked you to like graph each of the points and then show the problem fits what you said it fit. Either way. You did the math right. It should have worked out. And the way you can graph, you didn't have to literally graph the points. You could have just like checked what's going on at 0. Is it 3? What's going on at 4? Or sorry, at 1 is it 4? What's going on at 2? Is it 3? Number 64. Ugh. Does the system still work?
Yeah.
Even with decimals? Yes. Now they went ahead and did it a weird direction. I'm not sure why they did the weird direction. Our system would have had the xe1 on top and the y1 second and the z1 third. So don't worry about their weird system and the way they did it. I would have done stair step. You would have ended up with 94 degrees, 36 degrees, and 50 degrees. Degrees? What on earth were you doing? You were finding this sort of thing, and that's where the different equations up above came from. See the 180s? That was one of those geometry ones. And then with that, we're done. All right, kiddos, I'm actually going to go pause back to the beginning. Okay. Are there any evens? You guys have to see the answers. Any evens where you're like, yeah, I don't get how to start the problem, or I don't quite get how to finish the problem. Any evens? Is that 42? Any other evens? Okay. I think 42 is the weird 0 equals 0 one, right? All right. I'll take 42. But the rest of my volunteers going up to the boards all over the room. You can pull up the side. You can go up to the front. I'm going to pause the recording. And if you guys want pictures of the ones on the boards, just get them before you leave, because it'll get erased after this class. Cool. Actually, I'll keep the recording going, because I'm going to do 42. Never mind. Because if the problem was given to you, right? You didn't have to go find it or something. Okay. I actually wanted an example, just like 42. You're right then. Be smart about it. Alright, I'm solving 42. If you guys got stuck on that one, you can work through it with me and grab pictures of the rest. The guys are showing their work. If you guys are just chilling because maybe you didn't get to keep working on homework, maybe you can go borrow a book real fast and keep working on homework. It's not a bad idea. Okay, go for it. I don't care. Have confidence. You're showing initiative. Go get a book. Well, they're going to be working on that for a while, right?
Okay.
So probably at least 5 minutes. Maybe 10.
Can I get my spiral then?
Yeah. I was going to hand you a book, but if you want your spiral, you should go get that. You guys need the homework problems from either the section. Let's see.
I have it.
The Lonnie has it. You can ask her one. And I think I can almost.
Cliff's talking.
You should have A done. You might just not have B. There's B's problems if you guys need them. If you didn't keep going.
She gets her big. Why? I think it's important. After you do the second equation, I know stuff you don't know what to do next. After that.
Which second?
Like you did the second star, so
Oh, where this is coming from?
Yeah, because I do that and then I don't know where it goes.
It's from the second link. Because this one was from, that was from the first link. And then this one gets the second link.
So you're trying to solve it with the y minus 4z?
Oh, no. I'm holding on to that guy and I'm going to come back to him in a second. So now I have like a separate step. You see it? So that the first two, these ones,
Yeah.
I did elimination over here.
Yeah.
Now I'm separately taking the second two.
The second two.
See what I mean?
Yeah.
There you go. I'll do the line to separate. You're right, Kristen, it's kind of confusing.
I got you. I'm a professional photographer. Should I take the key now? Should I wait till we go over that?
Kiddos that did the work on the board, make sure you circle your answers or like what your final conclusion was, and just double check that you checked the back of the book that it matches. You know what I mean? So if you didn't check last night, double check tonight, borrow someone's book and be like, let's check the odd and make sure it matches.
What I couldn't hear is definitely not what I put up.
Oh, is it? It's
But does it match? That's the question.
signature.
I'm looking it up.
Hold on. Sean's checking, and then if his matches, I think the rest of them double check.
Because I was really tired.
Hopefully.
Yeah, so he's checking. He's checking.
He's checking.
Your process looks good, bud.
Is it I think you can't do? It might be this problem.
No.
It doesn't work?
Alright. No, it's just that my X is wrong.
Yeah, the x is minus a plus 3.
Yeah.
It's okay, I can't subtract 10 minus 16. Now I can.
Wait, 10 minus 16.
Yeah, I put negative 16.
Oh, yeah, you did.
Da,
Oh, you
da,
multiplied it by 6. The second group.
there, yeah.
Okay.
Hey, I see it. I
You
see
see
it.
it? Go get it.
Come on, get him, Sean. Wait, is the bottom column Sean?
I killed the seal. Go.
Wait,
I know. Sorry.
Oh, Z, yeah, thanks.
Come on. We love you, Sean.
Sean's the
Shout
goat. Hey,
it.
no one here on the goat. We can forgive you, Sean.
Thanks. For the love tonight. Tonight.
That was so good. Great job. Go team. I'm confused as to how you got
I know.
negative 6
What's wrong?
y.
Wait, 1 second.
Cheerios. Protein shake.
I was going to too.
You're confused with what?
How you got negative 6.
Cheerios are heart healthy, isn't it?
Nothing.
Yeah,
to
Cheerios.
I was trying not Cheerios.
I
If
didn't
they're
know
plain,
that
they need
my
like
banana
bananas.
I
Are
was
they
at work.
talking the wrong
I
one?
like bagel.
Oh, you did.
Oh, that's so. That's not good. No, you're not. Yeah.
Good question.
Dude, I heard this say it.
Oh, everyone's double checking their work.
Oh,
that's 3.
Race awareness, guys.
Oh my gosh.
We have time for that.
But
Oh, yeah.
I watched like an episode of it, and I was like,
Like, aside from
what
I'm here.
what on earth? Brian showed me an episode, like, there's so much drama.
It is. It's
Oh,
I'll go show you a screenshot. So I screenshot it.
No.
Watch one episode.
Okay, I first, I watched like Switched Up Earth for like 2 seasons, but then
Oh, Sora.
Oh, I
got
did.
sick.
Pretty good show.
And it was like,
Okay, I'm gonna take a picture of the work now.
And I kind of got a little
It is.
serious.
It's
I know
so-
laughing.
it's kind of bad.
stayed there for a while, but they finally came back. What are you talking about?
I
I watched 2 episodes of that thing. I got so far.
Yo, like,
I've been a
um,
fan since the beginning. I got to August. Yeah, it's in my house. You guys know the best person I know when I have to be
How'd it go? Did they make it match?
I was like, it did.
It's Jamie from
Check.
What you mean?
Alright, if you guys want a picture number 42, it's there.
Wait, I'm sorry.
Won't be there super long.
Thank you.
only when your third equation cancels out, like that one, 0 equals 0, and it's true. If it's like 0 equals 7, no solution. If it's 0 equals 0 or 4 equals 4, then we have to say
It's like
equals
so
a.
different. It's so and watch it funny.
Alright, anybody else see a picture number 42?
Hold on, let's see, hold on.
How I Met Your Mother. I like it.
No, I couldn't get into it.
Right? Okay, so I tried and like I got. It's one of those things you get midway.
My Shushers, you did an awesome job. Here we go. Here we go. P.S. Beware of lots of drama. That makes you think life should go a certain way and have certain super exciting things happen every single day. Sometimes the best things happen in the simple moments. So if you're just watching TV all the time, maybe you're not having those simple moments. Anyway, so here we go.
Where am I?
Miss Steve, we always have many Bible sessions. It's great.
Life is so much more than that, right?
Hey, some hard knowledge going on.
False. Very.
So happy.
Wait, what did you say?
Yeah.
Parks and Rec is so much better.
Oh,
Love Parks and Rec. Shots fired.
Wait,
Alright, here we go. Partial fractions. Here's the craziness of this section. This section is an introduction to something that will come back in Calc AB and Calc BC.
Oh, look at that.
This allows us, kind of like trig properties, to do the impossible in the future with integrals.
That's how we get into second.
Partial fractions will allow you to do the impossible in integration, which is a calculus thing that most of you don't even really know. It has something to do with this symbol-y thing. You see that? Yeah,
Yep.
that's calc. Anyway, yeah, they're doing it now. I think it's mostly erased now, though.
Funny.
It's not currently up on the board.
At first it was Ryan, but
Here, if you want, I can show you some of their notes, though. What was Calc AB doing this morning? Here we go. Look! They're all over the place! Little S-y things, but they're not S's. Good try. More S-y things. More S-y things.
What is the D?
More S-y things. They're everywhere this semester anyway. Okay, hold on, I just messed up the place in their notes. Let's come back. Partial fractions. It might seem kind of silly now, but it actually is very useful later. I need to, there we go, get back to your guys' notes, which is here. Okay. Here's the idea of partial fractions. We are decomposing fractions by going backwards of a problem where common denominators were gotten. We are decomposing, we are going backwards from a problem where common denominators were gotten. What am I talking about? Well, I'm talking about if we were to do something like, I don't know, arithmetic-ish, even though some would argue, still I say numbers, there are no variables. Something like this, right? This would be like a, I don't know, elementary-ish problem, kind of crazy, there are fractions. Algebra kids still hate this, maybe pre-calc kids still hate this. How would we put these two together? 1/7 I saw an algebra kid do yesterday.
Genius.
2 7s.
Common denominators, guys.
No 7s! We need close!
oh wow.
Right? Because we need 4 over 4, we need 3 over 3. And we end up with?
7/12.
Now wait. Question. Looking at 7/12, do you know exactly where that came from if I was to erase that?
Definitely not.
No. So this is a really hard thing to do with numbers, but it's actually much easier to do with algebra. Let me show you a different problem, okay? What if I was to do something like, ready? 3 over x minus 1 plus 2 over x plus 3. Okay? How do we put those together? That's much more algebra-ish.
Multiply by the
Denominator.
To get one side by x plus 3 and then multiply the other one by x minus 1.
Good job, Coco.
Right? Because I want my common denominator of x minus 1 times x plus 3, true? Okay. So we have x minus 3. Over here we have x plus 1 and, nope, x minus 1, I apologize. Remember, don't kill anything. Everybody's in parentheses, denominators are grouped. We would end up with, long story short, there's a 3x plus a 2x, that's 5x. We'd have a negative 9 and a negative 2, so a negative 11. I was really careful not to do anything illegal. It was of adding, not a subtracting. So question, and here's what we're trying to answer today. Could you guys be able to, after this section is done, tell me where this came from without knowing any of this? Wait, what?
let's get it.
That is this lesson. Where does that come from without knowing the beginning of the problem? So what you guys are writing down here, how to write a rational expression as the sum of two or more simpler rational expressions, how to take something that has been combined and break it down into its individual, smallest, simplest pieces. And those simpler pieces are called partial fractions. Okay, those first of all. How can we check to make sure this actually is a true statement? How can we check that? Yeah, do the same thing. We can just start on this side and say whatever. They must have gotten common denominators to put these two together, right? To take the parts and make it the whole over here. So then we can go ahead and say, all right, let's multiply this guy by x plus 2. Is that okay? All over. Well, all over. Plus, multiply this guy by x minus 3, and we end up with x minus 3 times x plus 2. Now, how did I get that? I said, well, this guy better be multiplied by the other side, right? And this guy better be multiplied by the other denominator as well. I know that these two should match at the end. So all I have to really worry about is what's going on up top, and that's what I showed down here below. Now let me erase all this messiness. Okay. So, how do we finish it off? 2x plus 4 minus x plus 3. 2x minus x is x. 4 plus 3 is 7. Does it work? Wait a minute, but these two don't match. I don't get it. FOIL. So x squared minus 3x plus 2x is minus x minus 6. Dun, 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 dun. Does it work?
Yeah.
I could even do like a snazzy t-proof and say t-proofs aren't just for trig, but we're not going to.
Okay.
Don't worry. Our goal in this section is not just to do math to one side and say, hey, you guys were right. Our goal is to take this guy and figure out our own way, well, a very specific systematic way, to find these on our own. So to do that, let's go ahead and get more into section 7.4. Oh dear.
Do we really need her
Is that a little rough? Okay, I'm going to highlight some important words. Now, this isn't quite like substitution elimination where you're like, I basically know it, so I will maybe write down words. Okay, actually get this down, all right? But I will try to highlight the most important because, yes, it's brutal. Decomposition. Wait, we've done decompose. Remember decomposing compositions of functions, f of g of h, and we had to pull them all out? Maybe not. Anyway, decomposing body, breaking down, breaking apart into its elemental pieces. Same thing here. We're taking a combined fraction with an involved denominator, complicated denominator. We're trying to break it down into its simpler pieces. Now, the very first step is super important. Super. Divide when improper. Before we ever start this entire process of decomposing into partial fractions, We have to check our fraction and see if it's improper. What does that mean? It's improper when the degree of the numerator is greater than or equal to. Greater than or equal to. You can think of it as a top-heavy fraction. 5/3, top-heavy, that's 1 2/3, right? 24/4. That one's boring. 24/5, that's top-heavy. That's 4 4/5. Rational functions might be a little bit harder to figure out when they're top-heavy, but they're top-heavy when the degree of the top is greater than or equal to, and that's where it gets tricky. Greater than or equal to the degree of the bottom. Divide when improper. Well, how do we divide two rational functions? Long division, of course. Long division, of course. So I'm going to go ahead and say, take your fraction and break it down using long division. You technically don't need to write anything else besides what's highlighted or what I have written in for number 1. If a fraction is improper, we got to divide first. If a fraction is not improper, go to step 2. After you divide, go to step 2. Step 2 says, okay, look at your denominator. He's the one that got combined. He was the decider of what everything got multiplied by, so he's important. Break down your denominator. Factor him as completely as possible. And technically we can say factor until it is irreducible. Factor until you can factor no more. That sounds kind of dramatic. Factor until you can factor no more. Now, they have all these snazzy things, like factor them into mx plus b and ax squared plus bx plus c factors. But guys, we've been factoring this year, and we'll review it some more this section, but long story short, factor until you can't anymore, okay? Number 3, well, here's the dealio. 3 and 4. I want you guys to write down this next. Make partial fractions. Now, you're not going to be able to make the entire thing because we have to solve for it. But make partial fractions out of. Supposed to be a dot, 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 and it's horribly failing. Make partial fractions out of. There we go. Make partial fractions out of linear factors, and here's the way to make them out of linear factors, and then quadratic factors, and here's the way to make them out of quadratic factors, okay? So this last part, make partial fractions, I apologize. Make partial fractions out of any linear factors that you have and any quadratic factors that you have. It depends on the problem. Sometimes you will just have these guys. Sometimes you will just have these guys. Sometimes you'll have both. So it just depends. Just depends. But I don't really know if you guys need all of this writing per se. It's just saying, hey, this is what you do. And what you do for linear factors is you write them of the form, and this isn't bad. The A1, A2, A3, blah, blah, blah. That's not a bad way of doing it. I might show it a little differently when I start actually solving. But long story short, A is a number that we're going to have to find, capital A, and capital B and capital C are numbers that we're going to have to find. So then our job after this step, and I'm going to put in a rule 5. Multiply both sides by, I'm going to put in parentheses, the common denominator. Multiply both sides by the common denominator. And then solve for unknowns. You might have multiple ones of them. solve for unknowns using, now here's where it gets a little tricky. Equations from the coefficients of like terms plugging in strategic, that sounds fun. Strategic, remember you have to develop a strategy, right? Plugging in strategic x values solving systems. And this is why it's in chapter 7, guys, because ultimately to do partial fractions, you kind of have systems of equations. Now there are some tricks for very, very simple ones, but we don't want tricks for simple ones. Simple ones we can theoretically do easier than harder ones. So even though there is a really snazzy trick, and if you talk to a BC kid, they'll say, hey, just the thumb trick or the hand trick. It only works on easy ones, and your homework and or quiz and or test will have some easy and some hard, so we have to have a system that'll work for everybody. You're going to solve for the unknowns, at which point you're basically done. You just have to rewrite the partial fractions from using any of these. I'm just going to put a little quick and or to say maybe you'll use A and B and C, maybe A and B, maybe B and C, maybe A and C. You don't necessarily have to follow some magical order with A, B, and C. It's just those are the tools with which you can use to solve. Now, sadly, this page has been a lot of steps, just writing down steps. It's not going to make a lot of sense until we start fleshing it out, aka working it out, aka seeing it in action, right? So let's see if we can get an example or two done before the bell. Still like what, 7 minutes? 8? You guys almost have it? A couple more seconds. All right. Peek real quick at how much space you need to skip if you guys haven't quite gotten to the end. I'll probably put this up at the very beginning of tomorrow. Because we're not checking homework tomorrow, right? Tonight is to start 4, no, not 4, 7-4. You know what? Hold on, pause. Do you guys really need to write this?
No, because we already did it.
Divide when improper, but we put more detail. Factor the denominator completely. Form partial fractions from these go together, and then we basically just need to set up and solve. So, don't worry, this is a quick little this is what we just basically talked about. 5 and then 6. Oops, undo. Let's go get one. Here he is. Wait, this was the beginning one. I know. Maybe you know the answer, but let's see how to get the answer from our steps. This was the beginning one. If you look back in your notes, you'll see the answer, but how do we get the answer? How do we break this guy down? Step number 1. We ask ourselves the question, is it improper? What would you guys answer? Is the top degree higher or equal to the bottom degree? What do I mean by degree? What's the degree of the top? 1, because the highest exponent of x is 1. What's the degree of the bottom?
2.
Okay, so is the top higher or equal to?
No.
Nope. So do we even worry about step 1? Nope. Step 2. Factor. Oh, yes, please, right? Factor who, though?
Denominator.
Denominator. So we're going to go ahead and factor the denominator. Hopefully this is a fairly easy one. Not all of them are, but this one is. Do you guys get x plus 2 and minus 3? No. Nice. Now we still have x plus 7 on the top, right? But factoring, check done, right? Factoring, check done. Step number 3, what does it say? 3 and 4, we're going to make partial fractions. How do we make partial fractions? Well, we look at these denominators. We look at each of the factors individually and we say, hey, x plus 2, are you linear or quadratic? And what would you say?
Linear.
Linear. So we're going to set up a partial fraction based on him being linear. 4x plus 2. 4x plus 2. We say we need a capital A on top. Does that make sense? If you want, go look at your steps. 4x plus 2. X plus 2 must have, or could have had his own little fraction with his own little coefficient on top. That's what's going on. And then we say, and x minus 3, you're linear also, and you could have come from, or you could have had your own little fraction, and you would have had a constant on top also. Now guys, we could make this A1 and make this A2, but why don't we just say A and B? Is that all right? Let's just say A and B. Okay, step number 2, we have our partial fractions set up. They're not solved, but they're set up. Okay. Step number, that was 3 and 4. Technically, we had no quadratics, so we didn't really need to worry about number 4. Number 5 says multiply both sides by just, I mean, it's algebra. You always multiply both sides, right? Multiply by the common denominator. Wait, who's the common denominator? X plus 2, x minus 3. Don't we have x plus 2 and x minus 3 as our common denominator? And don't you notice it's the same guy that's on the left? What we do to one side, we gotta do to the other. So basically we're moving that denominator to the other side. And what's gonna end up happening is everybody's gonna cancel out. Well, not everybody. Careful. This whole thing needs to distribute to both of my partial fractions, right? So I'm going to end up with x plus 7 equals, just for sake of you guys seeing it, I'm going to have a times x plus 2, x minus 3, all over x plus 2. I'm going to have b times x plus 2 times x minus 3. You don't have to show this every time once you figure out what's going to happen. What's going to happen to the a part when you bring in the denominator? Yeah, the x plus 2 is going to do what? Just like this canceled with the common, or with the shared top and bottom, the x plus 2 is going to cancel from him. What's going to happen over here with the b piece? The x minus 3 is going to cancel. Now careful, this whole thing, once again, has to go to both pieces. So I'm going to have remaining the following. X plus 7 equals a times x minus 3 plus b times x plus 2. Now, some of you are looking at this and being like, how on earth are we supposed to do? Well, pause. Step number 5 is done. Step number 5 is done. Step number 6. And guys, there are many different ways of solving at this point. I'm just going to choose one. Is to solve. For who? For A and B. But how? For today's example, just to finish it, I'm going to choose letter A. I'm going to choose letter A. You can go back and look at it tonight and peek at it. And letter A says, make equations from the coefficients of like terms. And let me show you what I mean. I have 1x on this side and 7 on this side. And when I distribute, basically, long story short, I'll end up with ax plus bx by rearranging minus 3a plus 2b. I need you guys to see something real fast. Do you see the x term? And do you see the other x terms? Do you see the constant term and the other constant terms? I can set up two equations and say 1x has to come from ax plus bx. And I can say 7 has to come from the non-x terms. Do we have a system? Wait, no, there are x's! Ew, gross, I don't like them! What can we do with x's? Isn't it the same thing as 1 equals a plus b? And 7 has to equal negative 3a plus 2b?
Oh, yeah.
So I'm solving with A, setting up like coefficients, and not B, sorry. And C, use systems of equations. Pourquoi or pourquoi? That's just a system. Shh, we got that. Substitution, elimination, we'll solve them real quick tomorrow. Bye, cool kids, I'll see you later. 7-4, we got a great start. But tomorrow we gotta flush this puppy out and see, does it get any harder than this? Bye, guys.